Good evening.
Good evening. Okay. Just a sec. Let's see.
Good evening, sir.
Yeah, good evening.
Good evening, sir.
Yeah, good evening. Okay. Yeah, so Elvin, if you want, you can record. I'm already recording it, but let me see if I can give you permission. Yeah, you have recording permission, Elvin.
Okay.
Okay, so last class we studied a very important concept called uniform circular motion. Okay, we talked more about circular motion topics. So we said something about uniform circular motion and non-uniform circular motion. We said how the speed is constant, whereas the velocity keeps changing because the direction is changing, right? So we talked about all those topics, and then we talked about centripetal force mv squared by r, and centripetal acceleration is v squared by r. Okay, excuse me. Okay. And then I try to explain you about centripetal force demand or required for a safe turn to be done. Okay, that versus the centripetal force provided. So friction, gravitation, electric force of attraction. So these kind of things are somebody is providing that force. Okay, so this is all the forces which are providing the centripetal force. But centripetal force calculation or required is calculated by mv squared by r. Okay. So I told you the entire class we didn't do any derivation at all. Okay, so the actual derivation we have to do it only in this class. Okay. Because as I told you, I wanted you to understand the centripetal force concepts properly. Okay, so derivation anybody can do it. Nothing very difficult at all. So if I consider a circle like this, if I consider two points, so this is R, this is R2. But remember, the vector is pointing this way, the vector is pointing. So even though the radius is same, right? This radius vector is different from this radius vector. So that's why I'm showing it as R1 and R2. This I'm going to call it as del theta. This I'm going to call it as velocity V1. This I'm going to call it as velocity V2. So if I extend this line over here, right? So carefully listen, this is a 90 degree because this is radius and this is tangent. This is radius and this is tangent, which means this and this are 90 degree. Okay. So this is 90, this is 90. So this is like a quadrilateral, which means if this is del theta, this must be 180 minus del theta. Sorry, yeah, 180 minus del theta. If this is a straight line, if this is 180 minus del theta, this has to be del theta. Anybody not following this, please ask me. So quadrilateral, so I'm saying that if this is del theta, this is 180 minus del theta, because this and this are 90 degree. 90, 90, 180, so that means the remaining is 180 minus del theta, which means this is a straight line, which means this is also del theta. What this means is the angle between R1 and R2 is del theta, means the angle between V1 and V2 is also del theta. Then I'm going to say this is R1 and R2. So this is R2 vector. This is R1 vector. This is del theta. This is the vector which I want, which is R2 minus R1. Final minus initial, which is your subtraction. Right? This is nothing but your del R. Similarly, I can say V2 and V1. So if I write this, so listen carefully, whenever you are doing vector subtraction or vector addition, I told you the tails must be touching each other. So this is a one vector, this is another vector. So I have to bring this tail over here. So that means I'll be seeing something like this. V2 will be along this direction. I told you vectors can be moved anywhere in the plane, anywhere in the paper without changing the direction. So that means V2, I have moved it over here. V1, I'm going to move it over here somewhere. Magnitude of velocity, this is we are talking about uniform circular motion. So since it is uniform circular motion, the velocity is changing, but then the speed is remaining constant. That means the magnitude of velocity means this length of the vector should be drawn same. So that means this will be same, which means this line here will be shown as this is V1 vector. So this is del E is equal to V2 vector minus V1 vector. Already told you, if the arrow is coming here, final minus initial. The arrow is coming here, final minus initial. R2 minus R1. Any questions in this diagrams? So this is the main diagram. This is, we are extending this or, drawing this separately so that you can understand the diagrams. What did I say about the angle between V1 and V2? It is del theta. So if this is del theta, this is also del theta. Now to understand that, you have to understand this quadrilateral. If you have any doubts, please stop me. And then acceleration is nothing but change in velocity by time taken. I told you the mathematics, we take the limit to be, delta t, assuming delta t reaches 0 or approaching 0, right? What it means is, I told you many times, if you take a curve like this, and if this is your V1, this is your V2, this is your T1, this is your T2. This should come closer and closer to T1. When delta T comes closer and closer here, becomes closer means delta T becomes 0. When that happens, this line will be your acceleration. So meaning the tangential line is your acceleration. If you calculate this line, the acceleration will be average acceleration. Whereas if you calculate this line, this is secant line, this is tangent line. So that means this is your instantaneous. So acceleration instantaneous means tangential line. So we have studied this many times. If you have any doubts, please stop me. That's where this concept of limit comes. So as you study this in your maths, it will make more sense. So if you don't understand this right now, don't worry about it. Just leave it as del V by del T. What is del V? Look at this. This is something like this is your change in velocity. So the change in velocity length is, even though it's a straight line, right? I'm going to assume that it is very, very small because delta t is approaching very small, we're approaching zero. Since it is a sector, right? So somewhere in your astronomical distances, we have talked about this. Even though it's a sector, sorry, even though it is a straight line, I can assume it to be a sector like this, okay? Which means delta V can be written as this into this using sector formula. So that means delta V, I'm going to write as V2 or V1, V into del theta. See if this makes sense. This length is nothing but this into this length into this length. But what is this length? It's nothing but the velocity V. So it doesn't matter. V1 and V2 vector is different, but the velocity magnitude is same. So that means if I write it as V2 magnitude, V1 magnitude is equal to V. So that means I can write it as V here divided by delta T. So what am I supposed to? Delta T by del theta by delta T is omega. So del R by delta T R. So okay, here actually I wanted to derive something else. This derivation is coming later. So I'm going to do a small change here. So look at this triangle and this triangle, right? So this radius and this radius are same. This length of the velocity and length of this velocity, magnitude of velocity are same. And this angle is same. So that means this is an isosceles triangle. This is also an isosceles triangle because these two sides are same. And since the angle is del theta is same, right? And then this is an isosceles triangle. This angle and this angle will be same. If this is say 30 degree and 30 degree, this will also be 30 degree, 30 degree, which means these two will be similar triangles. Okay, so make a note. Anybody not following this? This is an isosceles triangle. Any doubts? This and this both are isosceles triangle. So if this is 20 degree, this is also 20 degree. So if this is 20, this will be 180 minus 20 will be 160. 160 by 2 will be 80. So it will be 80 degree here and 80 degree here. So similarly, the same thing will happen here also. So this will also be 80 degree. This will also be 80 degree. Whenever the angles are exactly the same between two triangles, even though the length is different, the triangles are same, which means it will be similar triangles. Okay. So I hope everyone remember from your basics in mathematics, if you take a shadow of a triangle, right, this will be casting a very big shadow here. So the length will be different, whereas the angle, if you go and measure it here, this angle and this angle will be the same. So if you're throwing some light over here, okay. So this is ABC means this angle will be the same. Even though the length has increased, the angle does not change. This is a very interesting phenomenon in enlarging some substances or enlarging some shapes using a light or shadow. Okay, so the angle does not change. So that means what I'm trying to say here is the length is different, whereas the angles are same. So since the angles are same, they are similar triangles. So take it down. Both triangles are isosceles and they are similar triangles. Then I can do that. I can say that del since I said this is similar triangles, I can say that this by this should be equal to this by this. So del V by del R should be equal to V by R. Because similar triangle means corresponding sides will be proportional. So that means del V by del R should be equal to this radius by this radius. When I say radius, I am talking about the magnitude of the velocity. So this V by this R. Anybody not following this? So del V by del R is equal to V by R. So then what did I do here? So V del V by del T. So V del R into R. Okay. So del V by del T. So I gave you that acceleration is equal to limit delta T tends to 0. So del V by del T is change in velocity by change in time taken or time interval. So delta T is kept as such. So I'm taking this as V by R. So delta V. So from here I'm going to write delta V can be written as this comes on this side. So V into del R divided by R. So in place of delta V, I'm going to write this. And the delta T is as such. But I know that delta R by delta T is nothing but the velocity. So displacement by time is nothing but velocity. All of you following this? From here, I'm taking delta V is written as V by R into delta R. So del R by delta T, I'm going to write as V. So that means it will become V by R into V, linear velocity. This is nothing but your V squared by R. And what did we say? We are talking about acceleration here. And one more interesting thing to notice in the diagram. I told you I moved the vector from here to here. So look at the direction. So if I take this arrow over here, you will see that if you really do it in a proper diagram, right, proper scale diagram, you will see that this arrow will be pointing towards the center over here. So now itself we can see it. If I move this arrow over here, it will be somewhere here. Okay, which means it is pointed towards center. So that means this is a change in velocity direction, but that is nothing but your acceleration is change in velocity by time, which means this must be the direction of the acceleration. Everyone following? Yes, no? Acceleration is nothing but change in velocity by time. Time is a scalar, which means whatever direction you are getting for change in velocity, that must be the direction for the acceleration. So I'm saying change in velocity is in this direction, which means that must be the direction of the acceleration, which is towards the center. Yes, no, understood, not understood?
Understood, sir.
Okay. Nobody else has understood? Only one person?
Sir, understood, sir.
Okay. Very good. So that means acceleration is delta V is towards, so take it down. Delta V is pointing towards the center. So acceleration, somebody has not muted, so please mute. When you're talking, you can unmute yourself. So acceleration direction is towards the center. Okay. So since it is towards the center, we call it as centripetal acceleration. So that's the important derivation. So if they ask you to derive A is equal to V squared by R, that's all. Anybody still copying? Quickly copy this. If anybody is copying, I can wait for a few seconds. So I always say that, whether you are in 11th standard, 12th standard or college, if it is derivation, you have to study the derivation, understand it, and then you have to remember the starting point and ending point. If you don't know the starting point and ending point, you cannot do any derivations. You see, I was struggling with this one because I was trying out with some other method. I forgot this part. So that means you have to go back to this. Only if you follow this del V by del R, you'll be able to easily arrive at this. Okay. Nobody is copying still. I can change the screen. Next part of so that is one part of the derivation. The next part of the derivation is even more simpler, which you already know. So this is R, this is del theta, which means this is your del S, the small displacement. You can call it as del R or you can say del S. So velocity is equal to del S by del T. How much movement you are doing here divided by time taken, that is your velocity, linear velocity. But how to find this length? R into del theta. That is what we have been calling it as sector formula, delta T. What is del theta by delta T? Anybody? Angular displacement by time taken. Displacement by time taken is what?
Velocity, sir.
Velocity, sir.
Velocity. So angular displacement by time taken will be?
Angular velocity, sir.
Angular.
Yeah. So nobody is answering. Folks are sleeping. So this is your angular velocity, r omega. So it means we derived v is equal to r omega. So that was a is equal to v squared by r is the first derivation. This is your second derivation under this topic. Okay. Third is a is okay. Can you folks hear me? Am I still
Can
connected?
you scroll a little bit up, sir? I want to.
This one?
Yes, sir. Sir, yes, sir.
So just now a is equal to v squared by r. More accurately, you can call this as AC, centripetal acceleration. So C, some books will call it as radial acceleration because it is in the radial path, radial direction. Centripetal acceleration is also correct, or radial acceleration is also correct. Sometimes it's better to study both the names because you should not get confused later on. V is equal to r omega. So that means I'm going to write this as r squared omega squared divided by r. So r cancels. So I'll be getting r omega squared. So A is equal to AC is equal to r omega squared. So that is your third derivation. So you see all these things are very, very simple derivations, nothing very difficult at all. One more small derivation, I can say angular velocity omega is nothing but 2 pi by t. Why? Because 2 pi is the radians. This is the time taken for one full circle. So that means omega is how much time is taken for one's full circle. So 2 pi by t. Rotation or revolution or whatever you want to say. You know that 1 by t is nothing but frequency. So it means 2 pi nu. Some books will, instead of using this nu symbol, some books will use frequency. So nothing wrong if you write as 2 pi f. F stands for frequency. So it means we derived AC is equal to R omega square, but omega is 2 pi f or 2 pi nu. So that means R 2 pi nu the whole square. It's nothing but 4 pi squared R into nu square. Again, this I don't think we use it very often, but these two things, V is equal to R omega and A is equal to R omega squared, we use it very often. So it means this is just another additional derivation. Any questions here? I think 2, 3, 4 is very, very simple, nothing very difficult at all. The first one alone, you have to pay attention properly. Okay, understand this isosceles triangle, and then do this simple derivation. Only the starting point is usually difficult. Once you understand the starting point, after that it's just mathematics. Okay, anybody still copying this? Can I change the screen?
1 minute, sir.
So you can follow whatever your book is following. You can follow either F or nu square. Okay, nu.
Yes, sir.
Okay. One more small detail here is in your board exam questions, I don't think they ask you much of this, but you should understand that there are two types of accelerations in circular motion. So the acceleration which is acting towards the center is what we call it as AC or AR. So either you can call it as centripetal. Centripetal means towards the center. So centripetal acceleration, or you can call it as radial acceleration. But then listen carefully. This is the velocity direction. Okay. If I want to increase the speed, right, should the acceleration or the force direction should be perpendicular to it, or should be in the same direction, or should it be in the opposite direction? Which way should it be for the speed to increase?
Should be in the same direction. So.
Same direction, right? So why nobody is answering? So if I want to increase the speed, right, the force should be in the same direction. If I say force F is equal to ma, acceleration and force are in the same direction, which means the acceleration. So this is your AC and then the AT. So this we are going to call it as tangential acceleration. So the tangential acceleration is what is going to increase the speed. It need not be always this way. It can be in the reverse also. So this is ball is moving this way, but suppose if I say the acceleration is this way, what does that mean? If I say the velocity is here, and I'm saying the acceleration tangential is here, acceleration radial is here. So what is going to happen for the speed of the ball?
Reduce, sir.
Reduce, right? Since they are in the opposite direction, the speed will decrease. Since they are in the same direction, the speed will increase. Okay, so take it down properly. So this is what is called tangential acceleration. This is radial acceleration or centripetal acceleration. This is to increase the speed. This is to decrease the speed. can anyone tell me in uniform circular motion, what will be the value of tangential acceleration? In uniform acceleration, speed increases or decreases?
It remains constant.
Remains constant.
If I say the speed is constant, will there be any tangential acceleration or not?
No, sir.
No,
No.
which means it will become 0. So note it down. In uniform circular motion, AT becomes 0 because speed is constant. Will there be any AC radial acceleration or not in uniform circular motion? Yes, no. Uniform circular motion means it is going in a circle. If it is going in a circle, there must be something called centripetal force. If I say there is a centripetal force, is there a centripetal acceleration or not?
It's there, sir.
It's there, that's all. Why you folks are thinking so much? So that means AR or AC will be there. Okay, without this, you cannot have a circular motion. And finally, if you want, you can add one more small derivation, which is we derived AC is equal to V squared by R. And if I want F is equal to mass into acceleration. So since we are talking about centripetal force, I can call this as FC AC M into V squared by R. So that is your centripetal force demanded. So that is your fifth derivation. That's all. So any questions? So all the derivations related to circular motion is that's all very, very simple, nothing very difficult. Only the first part might be looking slightly, but it's all just mathematics. If you understand trigonometry, you can understand this. After that, second derivation, third, fourth, everything is just 2 steps. Even this is only 2 steps.
Sir, can you show it once again, sir? That FC. Okay, sir.
Again, sometimes you may not be seeing this in your textbook, okay? But sometimes you will require this for your numerical, or definitely you will require this for your entrance exams. So take it down. Nothing very difficult at all to study here. Once you understand the concepts, numericals will become easy. If you don't know the concepts, numerical will be difficult. Okay, let's see. Okay, I thought of giving you some more on this non-uniform circular motion, but I don't want to confuse you right now. When you're doing it for your entrance exam kind of numericals, maybe I can help you further. Okay, so circular motion is over. Okay, let's go to the chapter. What happened to my computer? Why is it so slow? Okay, so we're talking about fourth chapter. Okay, I believe I have gone through most of the important topics. Maybe one or two topics might be missing, so we can go through it. If you have doubts, you can bring it up. So let's quickly go through scalars and vectors. We talked about it, right? Triangle law of vector addition, parallelogram law of vector addition. We talked about it. You see, the theory looks very, very complicated. Okay, go through it. If you have any doubts, you can always bring it up. Okay, but I think I have made it easier for you. Position and displacement vectors. So we talked about position vectors. You see, P and P dash are position vectors, whereas P to P dash is your displacement vectors. So that's what is given over here. Equality of vectors, maybe I didn't talk about this, but whenever you say vector is equal, what it means is both the magnitude and the direction should be same. So that's the meaning of equality of vectors. So this vector and this vector are same magnitude, but since the direction is different, you cannot call it as equal vectors. Whereas this and this vectors are same direction, meaning with respect to the x-axis, the angle here and the angle here will be the same. So it means this and this are parallel, and then the magnitude is also same, which means it is an equal vector. Multiplication of vectors by real numbers. So maybe I can explain this. Again, all these things are mathematics. So so some of the things, just basics. So if I say this is, say, vector A vector, if I want, suppose if I write 2 times A vector, what is the meaning of that? It's nothing but the same vector direction, but then the magnitude is 2 times. That's the meaning of this. So that means this is 2A vector. Okay. Suppose if I want, say, 1 by 2 A vector, that means it will be in the same direction, but it will be half the length. That is your A vector by 2. Okay. So what this means is scalar multiplication. So I'm multiplying by a scalar. So that's why I think they call it as lambda into some vector. Okay, so that's what they are shown, and I already talked about minus A. So if you take it in the opposite direction, then it is your minus vector. Another thing I forgot to tell you earlier was, whenever you see bold letters in printed material, right? Bold letters means vectors. Okay, but you cannot, when you are writing in your notebook or somewhere, so writing this is much easier. Okay, if I say, okay, every time you have to do bold letter for this, that's going to be very, very difficult every time. So that means when we are writing, we will be following this convention. Whereas in printed material, usually this is a little bit difficult. Okay, so that means, of course, it's not difficult, but sometimes people use the bold letters. That means in printed material, this is your vector. In written language, this is your vector. Okay, addition and subtraction, we spent one full class, so I don't think I'm going to spend any more time. Commutative, what do you mean by commutative? Anybody?
A plus B equal to B plus A.
Yeah, so A plus B is equal to B plus A. So that means in mathematical terms, the reason commute means I'm commuting from my home to office, and I'm coming from office to home, something like this. And that is what is your commute. So commutative means if I say A plus B, is it same as B plus A? So if this is true, then we say the operation is commutative. If it is not true, then we say it's not commutative. So in the case of vector addition, it is commutative. How do you prove that? A vector plus B vector is equal to B vector plus A vector. So how do I know that? If I take A vector here, and then if I take B vector here, A vector is like this. So that means my resultant is going to be somewhere here. So this is my A vector plus B vector, vector addition. But here I'm supposed to do B plus A. So that means the first vector is B, then the second vector is A, which means, okay, again, no, again I'll be doing the same thing. So how do I do this? B vector plus A vector. So that means B vector is to be brought first. Yeah. Again, I think the diagram will this will be the same. So B vector is here, and then you are putting the A vector. Or maybe the parallelogram law of vectors will give you the same diagram. Let's try to do the vector law of triangular law of vector addition. So this is A vector, this is B vector. What does this mean? It means it is A plus B. This is B vector. So first I am putting the B vector, and then the second vector should be brought to the head of the tail of the second vector should be brought to the head of the first vector. So it means A is the second vector in this case. So that means I'm bringing the tail of the second vector to the first vector. This is A. And according to your law of vector addition, this is your B plus A. So you can see this, and you can say that this and this are equal, which means we prove that it is commutative. Okay, maybe this is not required. Because when you draw parallelogram law of vectors, no matter what, you will get the same diagram, which doesn't make sense. So maybe it's better to use the triangular law of vector addition. So what I'm trying to say here is this is your LHS, this is your RHS, which means you prove that they are equal. Vector addition is commutative. Prove. What can you say about vector subtraction? Do you think it is commutative or not commutative?
No, sir.
No, sir.
No?
No, sir.
Okay, let's see if you are correct. So A minus B. So A vector is here, B vector is here. So A minus B means final minus initial. So this will be A minus B. But in the same A to B, this is A, this is B. We said B minus A will be this way, which means it will be in the opposite direction. So maybe the magnitude is same, but it will be in the opposite direction, which means they are not commutative. So vector subtraction is not commutative. It's not commutative. So you can say A minus B vector. So this entire thing is vector. So it's not equal to B minus A. However, you can say that the magnitude is same. So that means A minus B magnitude is equal to B minus A magnitude. Why? Because this length and this length will be the same. Only thing, the direction of the arrow is different. However, magnitude is same. Okay. Any questions so far? Very simple. Okay, all these things are simple mathematics. Maybe that's why I didn't talk about this at the beginning. But now that you have a better idea about vector addition, vector subtraction, on how to apply the vectors in the applications, right? I'm sure you'll be able to follow this very easily. If you have any doubts, please stop me. Okay, so you can go through all these things. I'm sure if you understood the class notes, I'm sure you can follow this. Rain falling, we talked about it, right? Rain falling vertically with a speed of 35 meters per second. Wind starts. What's that? Anybody said something?
Sir, nothing, sir. I just meant to say that we discussed.
Yeah. However, I don't know if we discussed this because here rain is falling vertically and wind starts blowing after some time with a speed of 12 meters per second in east to west direction. In which direction should a boy waiting at a bus stop hold his umbrella? So can anyone tell me whether this is type 1 or type 2 problem?
Type 1.
Why type 1? One forces, when I say the rain is falling down, why is it falling down? Why is it not going up? Why should it fall down?
So it is due to gravity, sir.
Due to gravitation. So that means gravity is pulling the rain downwards. And there is a wind blowing. So when the wind is blowing, is it pushing the rain or is it pushing the boy?
So it is pushing the rain.
Pushing the rain, right? So assuming that the rain is very light compared to the boy, it's getting pushed. So the rain is getting pushed. So it means the wind force and the gravity force both are acting on the same object. If it is acting on the same object, what did we say? Type 1 or type 2?
Type 1.
Type 1. So that means you have to do vector addition. So you see this is velocity of the wind, this is velocity of the rain, which means this is your resultant. So this theta is what they're asking. Remember, they didn't ask you to find the resultant magnitude. They simply asked you to find the direction. So that means if this is theta, tan theta is opposite by adjacent. Opposite is this value. This is nothing but VW. So VW by VR. VW is 12. VR is 35. So 12 by 35. So tan theta is equal to 12 by 35. That's all. If you want theta, you have to use your data tables or calculator. Oh, they actually calculated the resultant using your Pythagoras theorem. But did they ask it? In which direction should a ball? Okay, they didn't ask the magnitude, but still they calculated it. Okay. Resolution of vectors. I told you resolving means making it into simpler, smaller pieces. Okay.
நான் வந்துட்டேன் இன்னும் 10 நிமிஷம் தான்.
Okay. Let's see. Again, these things are some mathematics background. Let's see. Okay, what this diagram shows is along with this, right? What this tells you is, again, you will be studying more about this in your mathematics later in your 12th standard or vector algebra. So for now, I will give you a small introduction. What this says is, suppose if I am able to write vector like this lambda into A, what is lambda into A? Some A times some bigger vector or smaller vector. So that means it's in the same direction. And look at this B. So mu into B means same direction, but the size might be bigger or smaller. So that means if I'm able to add this and this, and if I'm able to find A, then it means that these three vectors are collinear. Okay, so sorry, coplanar. They are in the same plane. We talk about the coplanarity here. Okay, so this concept is not required right now. Okay, we'll come to that later. So because basically we are saying that all the three vectors are in the same plane. So only when they are in the same plane, this is possible. If they are not in the same plane, suppose if the A is projecting out of this paper or computer screen, then you will not be able to write it like this. Okay, so that's the meaning of this. But this is little more advanced concept in mathematics, so we'll come to that later. Right now it's not required. We talked about ijk, right, and the unit vectors in the x, y, and z direction. So go through it. So this is ijk. I talked about axi. I gave it as a number so that it's easy for you to understand. We talked about this ax square plus ay square, Pythagoras theorem. We talked about how you can write this in terms of ijk, right? So ABC. It looks very complicated, but nothing very difficult here. Why would I write it in ijk? Because I can add all the i's together, all the j's together, and all the k's together. So that means addition, subtraction, all these things will become much easier in terms of ijk. So that's why we like to have it in ijk form. This is your vector addition and vector subtraction. So you can check it out yourself. Sine law and cosine law. So we derived all these things. Motor boat is racing towards. So this try it as a homework. Okay, nothing very difficult. Motor boat is racing towards north at 25 km/h. So that means its boat is going this way. The water current in that region is 10 km/h. So that means it's 10 km/h in the direction of 60 degrees east of north, east of south. So that means motorboat is going this way, the stream is pushing this way, which means the boat is going to go this way. That's all, very simple. Okay, so try this yourself. If you have any doubts, we can discuss that further. Motion in a plane, I took this derivation in the class. So go back and check this. So nothing very difficult. They are given it in a very difficult way, assuming that you know all the mathematics. But since you don't know the mathematics behind it, I would say just follow the class notes and that's sufficient. Acceleration, average acceleration, just now we saw this, del v by del t. Limit tends to 0. That's what is given here. Limit tends to 0. Yeah, look at this. This is what we are using today. Limit delta t tends to 0. So go back and check it out. We already done this derivations. Position of a particle is given by, so this is your position vector, where t is in seconds and coefficients have the proper units for r to be in meters. Find v of t and a of t. If displacement is given, how do you find the velocity? Hello. If displacement is given, how do you find the velocity?
So d by t,
Slope,
sir.
sir.
dr by
Gradient.
dt. So you have to find the displacement by time taken. So dr by dt. So that means you have to differentiate this. Okay, so maybe we can try this simple problem. Again, these are all mathematics. Okay, so if you know how to do differentiation, you can do this. So velocity is nothing but dr by dt. If you want to write it in vector form, you can write it like this, which means I have to differentiate this one. So d by dt of this entire thing, 3t I cap plus 2t square j cap plus 5k. If I differentiate this, 3 is a constant, keep it as such. T is, differentiation of t is dt by dt, which means it will be 1. I will be I vector in the same direction. So I told you, you can differentiate the X direction separately, Y direction separately, and Z direction separately. So that's why we are doing this. So I keep it separately. Plus differentiate this one. So 2, this is 2t square. So 2 comes in the front. T2 minus 1. Okay. And then J plus 5. So whenever you are differentiating a constant, it becomes 0 because with respect to time, it's not changing, which means d by dt becomes 0. Or if that is confusing, you can write this as, you can imagine that there is a t power 0, which means the 0 will come to the front. 0 into anything will become 0. Okay, because anything to the power 0 is 1. So if you, until you get convinced that differentiation of a constant is 0, you can think of it like this. That's all. So simply write this properly and you'll get the answer. So that means this is 3i, this is 4t, j, this is 0k. If it is 0k, you don't have to write this, but if you write it, nothing wrong in it. Okay. So that is your p vector. If I want acceleration, do the same thing. So acceleration is equal to dv by dt. So to simply differentiate this, you will get the answer. So differentiating this will become 0. Differentiating this is 0. So if I differentiate this, I'll be getting 4. So that means I'll be getting 4j. Because this becomes 0, differentiation of a constant is 0. Differentiation of this is already, there is nothing here. So that means I'll be getting only 4j. Find the magnitude and direction of v of t at t is equal to 1 second. So that means simply substitute t is equal to 1 second here. So that means so v of t is this much. Function of t is this much. So if I want it at 1 second, I have to substitute t as 1 second. So that means 3i plus 4j plus 0k. They said magnitude and direction, which means magnitude means v is equal to 3 squared plus 4 squared. If you don't remember this concept, you should understand that this is 3i here, this is 4j here, so that means the vector is somewhere here. So 3i plus 4j. So only then this Pythagoras theorem will come to your mind, otherwise it will not come. Similarly, if I want this theta, it is opposite by adjacent, which means this is y by x. So I told you tan theta will be equal to 4 by 3. Remember, sine and cos should always be less than 1. If I write sine theta is equal to 4 by 3, that is not possible. Whereas tan theta, tan 45 is 1, tan 90 is infinity or undefined. So that means in tan theta you can get more than 1. Take it down. Any questions? Please clarify it right now. Can you change the screen? Okay. So yeah, so square root of 3 square plus 4 square will give me Pythagoras triplets, which is 3, 4, 5. So we'll be getting 5. 4 by 3, you'll get somewhere around 53 degrees. Okay. Motion in the plane with constant acceleration. Okay, I don't think I talked about this, but it's already covered in the circular motion. So maybe you don't need this theory. If you know how to apply the concepts, I'm sure you can do it. So maybe we can try this again. Since most of them are some differentiation integration concepts, I'm trying to do most of the problems here so that you feel comfortable. This is the kind of problem which we did. Okay, rain is falling vertically with a speed of 35 meters per second. A woman rides a bicycle with a speed of 12 meters per second in east to west direction. What is the direction in which she should hold her umbrella? So it means now the speed of the woman is 12 meters per second, but the speed of the rain is 35 meters per second. So type 1 or type 2? Okay, I will keep waiting until somebody answers.
Type 2, sir.
Type 2, why? And nobody knows why it is type 2.
So rain is being pulled due to the gravity, whereas the woman is moving
Because
in
of
the other
bicycle.
direction.
Yeah. So that means the forces are acting on two different objects, which means we said it is type 2. This diagram might be confusing, right? But actually what this means is, this is the velocity of the bicycle and this is the velocity of the train. Since they said east to west, they are shown like this. So that means don't worry about this blue line here. You can show the blue line over here. Okay, which means you'll get the same answer. So the blue line is what I'm trying to say here is don't worry about this blue line. It's nothing but this angle. So velocity of the rain with respect to the VB. So that means VR minus VB. So that means I should write this as, so this angle is here. So that means this is your VR minus VB. Final minus initial. So what this means is, again and again I'm telling you, for a person who is standing here, the velocity of the rain is vertically downwards. For a person who is going in a bicycle this way, it may, even though the velocity of the rain is falling down vertically, since you are going in a bicycle like this, it almost appears like the rain is coming like this. And if you are going at a very, very high speed, the rain will appear although it is as though it is coming this way, which is theoretically possible. Okay. So even though the rain is falling down this way, if I, let's say, compared to the velocity of the rain, so this is your velocity of the rain. Let's say I'm going in a motorbike with a very high speed. So that means the velocity of the rain with respect to the man or woman is almost horizontal, because this velocity increases means this becomes more and more horizontal. Okay, so take it down properly. So this becomes almost horizontal. Okay, any questions? So after that, using the diagram, you should be able to calculate the angle. Nothing very difficult at all. This one, try it. Okay, again, this is differentiation methods. So try it yourself. Can come back to it. Projectile motion, we talked about this. Okay, so I think we spent enough time on projectile motion. Again, it may look complicated, but study your notes and then come to it. I'm sure it will look very, very simple. Time of flight. So we talked about Galileo's 45-degree fall shot thing. So use all these examples. So your homework is, okay, uniform circular motion. So this is what we talked about today, del V. So because of the vector symbols, it may look a little bit complicated. Okay, don't get confused. So just follow your notes. I'm sure it will become very easy. Yeah, so we derived this one, we derived this one, r omega square. We derived v squared by r. We derived v is equal to r omega. Yeah, you see, we derived all these things today. That's all. So I think we covered this chapter. So this chapter is extremely important chapter. Okay, so I hope you found it easier. Okay, so